Good morning and welcome to today's webinar. By way of introduction, my name is Nick Lane. I'm the Deputy CEO here at the Australian Airports Association. For technical assistance, please phone Redback support on 1800 733 416. If you also would like to listen to this webinar through your phone instead, please dial the number and passcode shown on the that's listed in the chat box. Today, the AAA presents its sixth and final webinar for 2017, and will be on the topic of asphalt and bitumen for airport pavements. It will be presented by Dr. Greg White, who's adjunct professor at the University of Sunshine Coast in charge of their airport pavement research program. Again, today's webinars are in a series of pavements-related webinars, specifically targeted around regional airports. The first webinar that we held earlier in the year was on Pavements 101. So this series that we're looking at will cover things, will continue to cover things such as splayed ceiling for regional airports, pavement thickness and ACN, PCN for regional airports, runway friction and skid resistance for regional airports, and pavement maintenance for regional airports. To ask Greg a question, please use the chat box, which is located on the left-hand side of your screen, just to the right of the cogwheel. After typing out your question, hit enter to submit. Questions will be answered throughout the webinar. Before we do start, I would like to take the opportunity to again thank Greg for his participation today. And without further ado, let's begin the webinar. Welcome, Greg.
Hi, Nick. Good morning, all. Thanks for having me again. This is the second in a series. We had sort of an overview in August. Now asphalt and bitumen today. Spray ceiling a bit later on, and generally these presentations are based around the APN, the Airport Practice Note number 12, Airfield Pavement Essentials, which we developed in the second half of last year, and we've tried to focus them on rural and remote airports. Wherever we can. Move forward. So a bit of a scope and an outline there. Questions as we go, if they relate to the topic, would be great. If they're more general in nature or not specific to what we're talking about, then any time, or we might save them to the end and try and tick off any unanswered ones when we get towards the back end. In a way, this presentation or this topic was inspired by two things. I got sick of hearing flight attendants on aeroplanes refer to parking aprons as tarmac, so I thought that everybody should use the right terminology. And also my wife, who, when I was explaining to her something about bitumen one day, she first called it tar and then called it asphalt, and I decided that the world should be better educated on the differences between the three. So to a large extent, that's what we'll talk about today, and that's certainly what we'll start with, defining bitumen and asphalt and the differences between them. Because if we don't get those right, then the rest of it won't make any sense at all. Bitumen is generally refined from medium and heavy crude oils. So by refined, it essentially means it's produced as a part of oil refining. It's black, it's temperature dependent, it's often described as a viscous liquid, which means that when it's hot it's runny, and when it's cold it's stiff and solid. The byproduct left over really from when we turn crude oil into LPG, petrol, kerosene, jet fuel, diesel, lubricating oil for your car and all those things. It's distinctly different from tar, which is a carcinogenic product which is actually produced as a part of coal, cracking of coal, which is a completely different process, and tar and bitumen should not be confused. One little confusing issue is that in the USA, bitumen is commonly referred to as asphalt cement because it's the cement or the binder that is in the asphalt mixture. So if you talk to an American and they talk about asphalt, what they mean is bitumen in our language. And if you talk to an American and they talk about asphalt concrete, then they're talking about what we call just asphalt, the whole mixture of bitumen, aggregate, and other bits and pieces. It's a schematic of what you get when you refine crude oil. So you have a tanker which puts the oil into a heating vessel, and then you've got a great big tube and at different temperatures up and down that tube depending on how high you are above the heaters. You get gas and things like that up the top. You get fuel and aviation fuel or jet fuel out of the middle. You get some oil for lubricating your cars and things like that near the bottom. And then you get this little bit left over down here. Oh, there's a little bit got gone. No, it's not playing. Anyway, down the bottom there on the right-hand side, you get asphalt, which you put in roads, airports, and other asphalt surfaces. You get a few other things out of there down the bottom as well, but asphalt, or what we call bitumen, is the primary one. It's a very complicated looking oil refinery, which is where bitumen is produced in amongst all those other products. A significant portion of that pipe work is just moving different products from one spot to another, and the other significant portion of those pipes is the heating system that heats and keeps those products at the right temperature so that they can actually move through the pipes. It's actually a relatively simple process in principle, but requires an extremely complicated piece of infrastructure to do it. Asphalt, on the other hand, is a mixture of aggregates, binder, or bitumen. Bitumen is really the raw material. Binder is if you've used it to bind asphalt together. Binders can be just bitumen, but they can also be modified bitumen. We add polymers and things like that to them from time to time. And what we generally call filler, which is usually in airport asphalt a hydrated lime, so a white powder, which is good for a number of asphalt properties. In terms of how much is in these things, about 11% by volume, not by mass. By mass, it's about half of that, but by volume, about 11% of the asphalt is bitumen. There's a few air voids in there, a little bit of lime, and the vast majority, more than 80%, is actually the aggregate or the rock component. Interestingly, though, that 11% by volume, 5.5%, 6% by weight of bitumen constitutes something like 50% of the cost of the raw ingredients that go into making asphalt. As I said, bitumen often has polymers added to it as well, and it's produced, or it should be produced, certainly in an airport environment, in a purpose-built production plant. This is a core of a typical asphalt mix from an airport somewhere in Australia. I don't remember which one, but you can see in there the large aggregate particles and then the smaller ones, and you can see the black bitumen, which is actually mixed in with the very fine material in between. That's not an Australian one, but it is an example of an asphalt production plant. There are lots of different examples, but essentially on the left-hand side you've got some bins that hold the aggregate separated into different sizes. So you put the biggest aggregate particles in one bin, then the smaller ones right down to the very small ones at the end. Sort of in the middle at the bottom of that photo are two heated bitumen supply tanks, and then all of that gets pushed into a big drum which dries out and heats everything up, and then mixes it all together and then spits it out through the hopper, which is sort of just below the white panelling on the right-hand side of the image, and a truck will drive underneath that hopper and the asphalt will come out and drop into the back of the truck, ready to go and do whatever it needs to do. A plant like that, that's probably at the more economical end, but they range in cost from somewhere between $4 and $10 million. You can buy them in a static mode, so you buy a block of land, you put it there and you use it on that block of land for the next 10 or 15 years, or they can come in mobile versions, which are essentially the same plant but just designed to be containerised and able to be trucked around the country and set up essentially wherever you require it for a short duration. That process of setting up an asphalt plant is quite expensive, and therefore if you don't have an asphalt plant nearby and you want some asphalt, you really need to have a significant quantity to make it viable. So we mentioned polymer modified bitumen or modified bitumens to produce what we might call binders. These are very common these days. 30 years ago, binder in asphalt was straight bitumen. Now, almost all the time, certainly in the airport environment, we're adding polymers or some other kind of additives to increase the properties and the performance of the asphalt by, in a way, reinforcing the bitumen. There are two types of polymers, essentially, elastomeric ones and plastomeric ones. The plastomeric binders make the bitumen good and stiff and hard, whereas elastomeric ones increase the stiffness, but they do that by making it very flexible and rubbery. So if you had two binders, one elastomeric and one plastomeric, and you applied the same force, the elastic one would give quite happily but spring back, and the plastomeric one would resist much harder or much stronger the force that you applied. Elastomeric is great for road environments because you've got lots of repetitions of relatively low load, and so it can sit there and give and bounce back and give and bounce back all day long. Perfect for loads. Not so sure that they're always the best answer in the airport environment, where we want something that's big and stiff, and because it won't get loaded that often, but when it does get loaded, it gets loaded in a very extreme way. So I personally prefer the plastomeric in an airport environment, unless you've got some unique cracking or something like that in your underlying pavement that you want to try and address as well. The polymers are expensive. They're about 50% of the cost of bitumen, even though typically you would only add somewhere between 4 and 8% of the binder content would be the polymer itself. Recently took the Sunshine Coast, the Whitsunday Coast Airport team up to a bitumen production plant in Townsville as part of their project, and Tony Schultz got to hold some polymers, and he was like a child in a candy store because we've been talking about these things for 12 months, and he finally had 1 or 2 polymers in his hands and could actually see, and that's what they generally look like. So that defines bitumen and asphalt, not uniquely to the airport environment, but in that context. We'll move now to where we use these things in our pavements. And we use them in more places than perhaps we might initially expect. Bitumen we certainly use in the priming of base course. So when we have a fine crushed rock or a crushed rock base course, we usually prime that with cut back bitumen. So it's bitumen essentially watered down, made even runnier, by adding in some kerosene or some other cutting material. And that helps waterproof the base course, and it promotes adhesion of the asphalt surfacing. When we're doing an asphalt surface, whether it be over the top of an existing asphalt or a new surface, we usually apply a tack coat. That's usually a bitumen emulsion, so bitumen dispersed in water, sprayable at ambient temperatures. And we spray that to the surface, and it essentially glues the asphalt to the underlying asphalt or to the primed base course. Of course, we use bitumen, usually modified, as the binder in our asphalt mixtures, as we've just been talking about. For those of us in very remote and rural areas, we use a lot of bitumen in spray sealing, and quite often that's a conventional or an unmodified bitumen, but increasingly it's a polymer modified binder And spray sealing for regional airports, I think, is something that would be worthy of us doing a significant amount of additional work in terms of specification, design and understanding, because these things are usually happening in smaller airports where perhaps local engineers don't have the benefits of specialist expertise readily available to them, and those tend to cause some challenges from time to time. For those who have had an existing asphalt surface that have tried to preserve or enrich or rejuvenate it, there's almost certainly some bitumen of some description in those rejuvenating products. Various versions of those have been used over time, and in a couple of webinars time we'll have a bit of a session on pavement maintenance, and we'll talk about those in more detail then. I'll probably also get a Guernsey in the friction webinar, because they're very important from a friction management perspective. Another use that's not so obvious for bitumen in pavement is as a dust suppressant. So bitumen emulsions in particular, so that's bitumen in water to make it sprayable at ambient temperature. They're very useful for suppressing dust. So they quite often can be used on temporary access tracks and those things to reduce dust during the construction of a project. And similarly for flank work, most of our airport asphalt overlays will also require some form of raising of the flanks immediately adjacent to the pavement surface, and bitumen emulsion, usually with grass impregnated, which is commonly known as hydromulch, is fantastic for that, because it helps distribute and protect the grass seeds. And for some reason, if you want to make grass grow well, you spray bitumen on it. I wish I understood the science behind that. I have a layman's theory that I won't bore you with, but it seems to me that if you want your grass to grow better, just spray it with bitumen, and it grows quite happily with not too much water required. So that covers how we commonly use bitumen in our pavements, and again, not specific to airports, but certainly applicable to the airport context. In terms of some of the, almost if you like, myths and facts about bitumen, the reality is that bitumen is a byproduct of producing high-value products like LPG and fuel and diesel and jet fuel out of crude oil. Because it's a byproduct, it's not necessarily controlled in the same way that those other products are controlled during the production process. And therefore, bitumens from different places can have significantly different properties, and they'll change depending on the source of the oil, depending on the refining processes that have been used in the production of kerosene and jet fuels and LPG and diesel and those other products. Quite often, other byproducts or waste products from that system will be re-put back into the bitumen as an extender, as a way of bulking out the bitumen. And then once we get bitumen to Australia, we then finish it off in different ways. And those different finishing processes can also impact the properties of the finished product. Before 2011, Australia essentially predominantly made bitumen. So we purchased crude oil from somewhere in the world, primarily from the Middle East. We imported that in big ships, and we turned that crude oil into bitumen in our own refineries. now in 2017, we predominantly import bitumen as a finished or at least a semi-finished product. Now, we'll talk about that a little bit more in a minute and what that might mean. But it's also important to recognise that that occurred over a 3 or 4 year period between about 2011 and 2014 and has had a significant impact on our bitumen supply chains in this country, to the point where the companies that did that production locally in 2011, none of those companies exist in Australia as bitumen suppliers today. They've all been, all of that ownership has changed to traders as opposed to what we might have traditionally called refining companies. The other thing that is certainly a fact is that there are no tests in our current specification that are intended or reliable for the prediction of performance of bitumen, and certainly not of the performance of asphalt. So the impact of the bitumen's performance, or the bitumen on the asphalt performance. None of the tests in our bitumen specs control performance of our end products. A couple of questions that seem quite relevant at this point in time. Somebody's asked the 1% lime. Lime in asphalt can do one of two things. So lime is usually incorporated into asphalt as a fine white powder. And it's actually sort of metered in with the other dry products during the asphalt production and mixing process. And lime does two things. If you have an aggregate source that has only a very small portion of fine material in, you can add some lime to essentially correct the grading. Typically, we'd be looking for about 5 to 6% of the overall aggregate being smaller than 0.075 millimetres in diameter, so very small material, and lime will supplement that if you have a particular aggregate source that's deficient. The other thing lime is very good at is it promotes moisture resistance. So it's actually primarily in there to stop asphalt stripping, which is water damage that actually gets in between the aggregate particle and the bitumen film and separates them. There are a number of airports that have had this issue recently. The 1% lime is traditionally intended to reduce the risk of that occurring. The polymer modified binders certainly appear to help reduce that risk as well. There are other products called liquid anti-stripping agents that can be used in lieu of hydrated lime to essentially achieve that same moisture resistance, but in a different way. And that's extremely useful where you have an aggregate source that's got lots of fine material in it, and you don't want to add any more and create an asphalt instability by having too many fines. So we'll leave the lime out and put in a liquid anti-stripping agent, which essentially just promotes the bond between the bitumen and the aggregate particles. The other question is about environmental concerns that preclude the use of bitumen in hydromulch on the flanks. I acknowledge and agree that at some places that concern has been raised. I must admit, we mix bitumen into gravel and put it in the ground to make all kinds of things, including asphalt. I've never been convinced that spraying some bitumen on the surface of the plank necessarily creates an environmental concern, but I certainly acknowledge that there have been examples where surf has been used only because of the perceived environmental concern of spraying bitumen on top of the flank material. So that's a good point and well worth being conscious of. Although I'm not an environmental person, so I couldn't necessarily comment on the validity of the concern, but it's never really rung alarm bells to me. Going back to bitumen and importation, this is a couple of our couple of images provided by two of our biggest, or our two primary bitumen suppliers now in this country. You can see on the right-hand side is our national bitumen importing and refining location. So I think there it shows that in the upper image in 2000, and that would have been the case almost up until 2010, I suspect, we had 1, 2, 3, 4, 5, 6 refineries turning oil into bitumen and fuel and other products, and 3 importing facilities where finished bitumen could be imported. And then if you flick down to 2015, the image directly below on the right-hand side, you could see that there's only 2 of those refineries left, and I believe the one in Perth is no longer refining, which means there's only one left, and all of those others have been converted to bitumen importing terminals, which just illustrates that trend. The image on the left shows, and it was as a promotional piece of information, all the different places that this particular bitumen importer can source its bitumens from. And you can see there from Thailand, from Korea, from Indonesia, from the States, from all over the world we could be receiving our bitumen, which is probably good from a redundancy perspective. I did ask the supplier, if we had drawn that image in the year 2000, what would it have looked like? And he said it would have been one great big arrow from the Middle East to Australia. And that really reinforces that imported bitumen isn't necessarily any worse or more concerning than local production of bitumen from imported crude oil. But the important thing is that when it's being imported from all over the world, the diversity and therefore the range of properties are that much greater than if we were just receiving it all from the same source, so we knew what was coming every day. A bit like if you drive a Ford Falcon every day, you know where the indicators are, you know where the lights are, you know where the on-off button is, you know where the handbrake is, you know how to drive your car. If then one day you all of a sudden jump into a Holden Commodore, or let's say a Volkswagen, the indicators are on the other side, and whilst that's not necessarily bad or worse, it's just different and not familiar, and can create some issues whilst you're trying to get used to that new arrangement. So I think in the past we've been critical of imported bitumen, and I think it's less about the change in quality that's associated with imported product, but it's the variability and the fact that we now have to work harder to understand what we're getting and what we need to do to it to make it perform in the field, remembering there are no performance tests in our specification. Asphalt for airports. So this is just a little summary on what airport asphalt is and why it's like that, and some examples of things that haven't turned out quite the way we might have hoped in the last few years. Anybody who's seen me talk about asphalt at some of the conference events would have heard reference to Mr. Marshall, who developed our method of designing our asphalt mixtures in 1939. Was a bit adapted by the US Army Corps of Engineers shortly thereafter, but it essentially hasn't changed since 1950. Mr. Marshall's method is very recipe-based. So it says that if you take X of this, X grams of that, and mix it with X grams of this other stuff, and X grams of that other stuff, you'll get a really nice shake. And if you do that every day, it should always be the same. The tests that are used to determine whether something is the same or not aren't performance-based tests. They're essentially tests to screen for inconsistent production. So if you only put half the flour in, or you put twice the eggs in, you'll get a mixture that's not as consistent or runny or solid as it was the day before. And that's the kind of test that we have in our Marshall asphalt mix design traditionally. And but for many, many years, we had very low rates of distress in our runway surfaces. However, about 10 years ago, we started to see some concerning issues. We saw some shearing, and I've got a photo of this in a minute, some cracking, and some groove closure. The things that we hadn't really encountered in significant ways in the past, and those things have led to a transition towards more performance-based testing and more performance-based asphalt design, and even now to alternate mixtures, sort of disregarding Mr. Marshall's traditional recipe-based mix and looking at some other types of asphalt that might be more appropriate that have been developed in Germany and the rest of Europe in the last 40 or 50 years. Important, I think, to understand that those shearing, cracking and groove closure issues, they're very complicated and we don't absolutely understand what's triggering them, but it's likely to be a combination of the increase in aircraft loading, in particular high tire pressures and high individual wheel loads, which would seem to be a trend that we will continue to have to accommodate for some time yet. And the other thing that is probably contributing to that is this variability of bitumen supply introduced by or as a result of the importation of the majority of our bitumen, and the fact that, again, not that imported bitumen is necessarily worse, just that if we know how to treat bitumen source A and then tomorrow we suddenly get source B and we're still treating it like we are A, we'll end up in our car with our indicators on when we tried to turn the lights on, or vice versa. These are just a couple of examples of those distresses, and again, if you've seen my presentations at the various AAA and other conferences, these won't be unfamiliar. Groove closure, which has required a couple of airports to resurface significant portions of their runways for no other reason than because their grooves were closed and well ahead of schedule. Shearing, which in itself isn't necessarily a significant failure of the surface, but when it gets to the point that there starts to be a crack and then a tear at the back end of that area, then people do start to get a bit worried. And cracking, this is the severe top-down cracking, and these cracks seem to form in parallel gangs and then eventually chunks, as shown in the top right-hand image, can start to come out of the surface, and those chunks clearly end up somewhere, hopefully not in aeroplane engines. Just revisiting quickly, our airport asphalt is usually a 14mm sized mixture, which means the biggest aggregate particle is 14 millimetres in diameter, at least notionally, or supposed to be. They're generally grooved for texture and for friction, or effective texture, and skid resistance, probably more correctly. And those layers are built usually 40 to 60 millimetres thick, and importantly, they cost 5 times as much as a sprayed seal in a typical regional airport. So if you've got a sprayed sealed surface, and I'm currently working with Dubbo Airport, they've got a sprayed sealed surface that they're about to put asphalt on. They could have continued to reseal that surface every 10 years, and it might cost them $1 million a go, but they're going to put asphalt on it, which they might then have to resurface every 10 to, if they're lucky, 15 years. But each time they do that, it's going to cost them 5 times as much, and they certainly aren't going to get 5 times the life out of that asphalt. So there has to be some other driver other than the period between resurfacing to prompt an airport to upgrade from a spray seal to an asphalt surface. Is bitumen changing? We talked about this a little bit already. As I said, it's hard to really understand because a lot of this stuff is proprietary in nature, and it's not necessarily all that transparent at times. But certainly we get more diverse sources. There are more efficient refining processes. If you look at a graph that shows how much diesel was gotten out of every tonne of oil, it's increasing steadily, and at the same time bitumen production decreases at about the same rate. So they're effectively converting bitumen into more diesel. Crude oil quality is declining. There are a couple of measures of crude oil, one around density and one around phosphorus content or sulfur content, and density, and one around phosphorus content or sulfur content. But those two indicators both suggest that the actual oil quality that we've now got is not as it was 10 or 20 or 50 years ago. And we're adding a lot of polymers to almost all of our asphalt to overcome some of these issues. But all of that only matters if it affects asphalt performance. But I think the important thing is that when we change from source A to source B, we quite often don't know in enough time to change the polymers or the processing or the finishing that we might do to it, and that's where we seem to get caught out with some performance issues. I think it's fair to say that bitumen for airport asphalt is probably the most challenging aspect of airport pavement design in the year 2017. Here's an example graph that just illustrates some of this variability stuff. So these are all samples of the same type of bitumen. So, and this is viscosity, which is essentially its runniness at 60 degrees. And you can see here that at year 0, and year 0 is defined as the year that it was produced, so 0 years after each particular sample was produced, and they were all produced at different ages, but they were all tested when they were produced, and all of those sit in that band between 4 and 6,000, which is the specification band. So all of them complied with their specification. Some of these were all samples that were put into tins and retained in a dry indoor environment over a number of years, up to 4, although some of those lines do extend beyond. And you can see there the difference in changes over time. This is all for theoretically the same type of bitumen. So you can see there the dark green line is essentially a flat line. Actually, that was tested after 8 years and it hadn't changed 8 years after it was produced in terms of its viscosity, not by more than a few percent anyway. And then you have a few like the orange and the blue lines, which increase over time. Now, in theory, the green line should be the norm. Then you've got the red line, which was reasonably flat for 2 years and then accelerated up after 2 years. And then you've got probably the most concerning one, which is the 2013 light green sample, which is already, or when it was tested only 2 years after it was produced, it was already double the stiffness or the hardness of what it was produced at. And this isn't out on the runway where it's exposed to heat and oxygen and the sun and all those things. This is inside a sealed steel tin, inside a cupboard in a laboratory. All those lines should be flat. So that's just an example of how what should be a constant material can jump around a bit. This does a similar thing, and that's actually project data. But essentially, what that shows is that over a 12-month period as work progressed down a very long taxiway, with a couple of breaks for winter and Christmas and other things. The job received 3 different sources of base bitumen, and the red crosses show where the polymers that were added to that bitumen to produce the polymer modified binder changed 8 times over that period. And if you do some statistics on that data, things changed significantly over time, as did the performance of the asphalt that was going on the ground in terms of early life rutting and shoving very early after the asphalt was produced. Question about how polymers affect the cost and all the processes involved in the asphalt mix, especially in remote areas. That's a good question. So typically, these things go up and down just like the price of petrol does. But typically, the cost of base bitumen at the moment is something like $900 a tonne. You might add $400 a tonne for the polymers that would typically go into that bitumen to produce what we would now call an airport-suitable PMB for runway resurfacing. So it adds significantly. That's for the bitumen cost. When you translate that, I have to do some math to translate that into the cost of your project. But you might, it's not going to double the cost of resurfacing your runway. It might add 5 or 10% to the cost of resurfacing your runway. I'll have to do a bit of math to see if that's right. But it's not going to add 30 or 40 or 50% to the cost of an overlay. But on the flip side, I would be, certainly in a hot environment, I would not be endorsing unmodified bitumen in runway surfaces, especially when they're grooved and they're for any significant, and I really mean Q400 or larger aircraft servicing that, being serviced by that airport. There was an airport in that side of the country, the western half of the country, that did that not so long ago, and within 2 years of resurfacing their runway with what they had traditionally got good performance out of, standard unmodified C320 bitumen, they resurfaced a third of their runway because all their grooves had closed, for no other reason than because their grooves had closed. And that was, I have no doubt, significantly impacted by the absence of polymers in their binder. That brings us to really the end of the content that I was intending to cover. And any questions, and this is when we'll get flooded, but that's okay. There's one here. In short, what would you expect to happen to the friction characteristics of an element? Well, I think the question is, please tell me if I haven't got this right. The question is, if I've got a typical airport asphalt surface and I don't groove it, will I pass my friction and surface texture requirements? And the answer, so CASA requires, it'll be good discussion for a future seminar, but or webinar. But in short, CASA requires to have adequate levels of friction by friction testing, so a grip test, a type test, and or 1 millimeter surface texture, or to groove. So if we don't groove, we need 1 millimeter surface texture or adequate friction. Airport helping just put new asphalt on their surface. They had it tested before grooving, and the friction results were marginal to the point where they couldn't be left. It couldn't be left ungrooved over the wet season based on the results that were available. So you'll be unlikely, at least in the early stages, to meet the friction levels. Although you might be lucky and just get there, but it wouldn't be reliable. Usually, I would expect that an ungrooved asphalt will have a surface texture of between about 0.4 and 0.6 of a millimetre, so well below the 1 millimetre that CASA requires us to have. So my view is, if you're resurfacing your runway and with our current dense graded asphalt, and you want to, and you have to achieve either the friction or the texture requirements, then really you've got no choice other than to groove. And that's not really going to be any different whether you're Brisbane Airport or, I don't know, Kununurra Airport. I've got, oh no, that's a couple more questions coming, but yeah, we didn't get, oh, here they come. So if the question is, what is the recommended percent of C170/PMB in airport asphalt? So firstly, even when we didn't use polymers so much in our airport asphalt, we didn't use C170, we used the harder C320 grade of unmodified bitumen. Typically, airport asphalt based on Mr. Marshall's method and our traditional specifications will have between 5.5 and 5.8% bitumen by mass, which is about 11% by volume. But there are some outliers to that rule because you have to, it's dependent on the aggregate source and how tightly the aggregate sort of fits together, because that will tell you how much air is left in your asphalt if it's got no bitumen in it, and you want to fill about 75% of those air voids up, so that you've still got plenty of air voids, so you don't flood the bitumen or the asphalt. You don't flood the bitumen through the asphalt and create instability, but you also don't want too many air voids to allow the air and the moisture in and cause your asphalt to age prematurely. So typically 5.6, 5.7 could be anywhere, to be honest, from 5.2 to 6.1, depending on a lot of things, primarily the aggregate that you're using. In terms of, and that wouldn't change, whether you're putting in C320, a proprietary PMB, an elastomeric PMB, multi-grade, it makes no difference which binder you use. That 5.6, 5.7 bitumen content is pretty much the same all the time. Well, that's a good question too. If there's a lot of risk due to variability, does that mean we should be resurfacing all at once or spreading out the risk with different contractors and sources? That's an excellent question. It depends on if you can get good stuff on today or not. If you can get good stuff today, you'd do everything, wouldn't you? If you know that you're going to not get great stuff today, then you would only do what you absolutely had to do and wait and hope you get better stuff another day. Probably the reality is we never purposely get not so good stuff, and we don't have, because we don't have those performance measures in our specification for bitumen, we don't really know whether today's batch is some of the stuff that we're comfortable with or some of the stuff that's going to cause us a challenge if we haven't reacted to it. But we should give our asphalt and bitumen industry some credit. They're not just sitting back and saying, well, it's not our problem, it's just what we get. Sorry guys, that's the way it is. They're actually taking active steps to work more closely with the bitumen importers around the world so that they have a better feel for when things are going to change and what that change is. So when we were at that bitumen importing terminal in Townsville, the chap that runs that facility was explaining to us that every time a ship leaves Singapore or wherever it leaves to come to his terminal, 2 days later, so 3 or 4 weeks before the ship arrives, he gets sent a sample of that product so that he can test it and has got time to put different things in place if that particular source needs some different processing or handling or some change to its polymers. And the asphalt companies are doing the same kinds of things. So there's really now a more active interaction between the people bringing bitumen to Australia and the people who are turning that bitumen into asphalt for us. Best performance test to confirm that dense graded asphalt is resistant to wheel path deformation in the asphalt layer? But that's a good question, and there's probably two approaches to those tests. One is, if you like, laboratory tests. So there's a test called the flow number test, where you essentially take a cylinder of asphalt and you compress it repeatedly, thousands of times, and then you measure how it deforms both laterally and vertically. And I like that test because you get a shape of deformation out of that, and the shape gives you a good indication about the contribution of the binder to the asphalt resistance to deformation, but it also gives you a good indication of the aggregate's contribution, so you can separate the two apart better than other tests. The alternate to that is the wheel tracking type test. So we do that routinely as part of asphalt mix design. We can't relate it directly to performance in the field, but we can relate it very well relative to other mixes and other bitumens and other asphalts, and that's readily available. The flow number test is really a research tool because the asphalt production laboratories within our current industry don't have that test available to them. South Africa developed if you like, a beefed up version of that wheel tracking test. It's almost like a full scale or a semi-scaled test, and it has a range of capabilities that our simple machine doesn't have. But there are none of those machines in Australia. Although it would be an improvement, I'm not sure it would be a substantial improvement. But certainly, from a research perspective, that flow number test has got a lot of benefits to it. Are there any tests to classify whether a batch of bitumen is good or bad? There are lots of different tests. All of our bitumens pass all of those tests. They're things like if you heat it to 200 degrees, which is going to happen when you make asphalt, will it catch on fire? If you mix it in bitumen in water to make bitumen emulsion, will it stay stable and in emulsion? But in terms of performance, good and bad, there aren't in our current specifications. There are tests around the world that claim to be better than, if you like, the traditional tests. But I think there's still some question marks on how reliable those tests are for our Australian bitumens, because unlike many other parts of the world, because we're so hot, we have a lot of polymer in our bitumen, and those tests are not necessarily geared towards highly polymer modified products. So I think that the principles of those tests are sound, but they probably need some adaptation to make them more applicable to our materials here. So I also think that from any particular source of bitumen, you can make good binder for airport asphalt. It's a matter of how much of what polymers you put in there. And it's not, as I said, it's not that the imported bitumens are necessarily not as good, they're just more variable because they come from more different places more often. And it's reacting to that and having a system that allows us to test it, evaluate it, understand it, and then react accordingly. That's probably what caught us out as we transitioned from a country of bitumen producers to bitumen importers. Alternates to grooving. Yes, there are. So, for example, there's a material called stone mastic asphalt, which is just another type of asphalt with different grading and different things. Stone mastic asphalt is used routinely in Germany, Belgium, and a few other countries in Europe as their runway surfacing of choice. Stone mastic asphalt is the runway surfacing of 30, I think it's 32 of the 35 biggest runways in China. So actually have a RAF Master of Engineering student who will be doing research next year on working with our asphalt industry to develop a specification and then validate that specification, put stone mastic asphalt on runways in Australia. So we're making some steps in that direction. There are other products, and one called BBA, which is a French product, has similar kinds of surface textures that exceed 1 millimetre reliably without needing to be grooved. So there are products available, and we haven't used too many of them here. What have we got on here? Any issues with transporting PMV? Yes, most definitely. In particular, the elastomeric PMVs. Most parts of the industry accept that if you heat them up and use them within 48 to 72 hours, the risk is low. After 72 hours, the risk is greater. It's greater. It's either a lot greater or only a little bit greater, depending on whether you're carting it a long way, heating it very hot. In contrast, the plastomeric PMVs, which I think are more suited to runways anyway, are less prone to degradation during transportation. It's just the nature of how they work. There are also opportunities to transfer the bitumen or the PMV into shipping type containers, allowing it to fully cool down and then reheating it once it's on site just before you want to use it. And if you do that and you heat it in a careful and appropriate way, then that risk can also be quite significantly reduced. Nick, aircraft weights and tyre pressures and wheel loads, and will that mean thicker asphalt layers? I think the answer to that is it's already happening. The new runway at Melbourne, the new runway at Sunshine Coast, the new runway at Brisbane, the runway just upgraded at Proserpine, they all adopted 100 millimetre asphalt surfaces or more, which is essentially 2 layers where there probably only would have been 1 layer over the crush rock base course in the past. So that's already happened. However, no matter how thick you make your asphalt, your grooves are still at the top of it. So increasing asphalt thickness won't help reduce the risk of groove closure. You actually need a more resistant material to be able to better resist groove closure. There's no way to do that by making your pavement or your asphalt thicker than it otherwise would be. So probably time for one more question, and then we probably need to wrap it up, but it relates to the evolution of friction and whether it gets better or worse over time. Friction significantly increases in the first few months after an asphalt surface is put down, because the very fine bitumen film that is on the very top of the most top aggregate particle, the very, very surface that you can see when you walk on the pavement, it gets washed off or worn off relatively quickly by the action of rain and aircraft tyres. And once you remove that thin film and you expose the aggregate underneath, you get a bit of a better friction. Then over time, the mastic, which is the mixture of the bitumen and the fine particles, erodes from between your asphalt, the aggregate particles over time, so you get more friction as a result of that. But in the counter to that, you've got tyre rubber and other contaminant building up, which reduces your friction. Your friction will actually, your measured friction will go up depending on whether your surface is wet, your surface is dry, your surface is hot, your surface is cold. Your aeroplane tyre is hot or your aeroplane tyre is cold. So all of those things will actually affect the braking efficiency of the runway at any given time. But generally it will increase as the surface increases in texture. but then you might go and put a rejuvenation or a preservation product on it after year 7 or 8, and that will significantly reduce your friction again. So it's changing all the time. It's changing seasonally, it's changing as the asphalt surface ages, it's changing as rubber builds up and then you remove it, or as after you treat it with a rejuvenation product. I think it's smack on 11 o'clock, so we one more good question. Thanks, Ellie. The requirement to tack coat between 2 new asphalt layers in the same shift, I say no. We recently tried it both ways at Proserpine, and I could not find the interface between the 2 layers when they were built on the same night. They were essentially homogeneous. If you've delayed it by more than a week, then I believe yes, because I think even a week and the cooling of the asphalt has the potential to cause you issues. And for the very small cost of tack coating, I think it's worth its weight in gold. And with that I'm going to stop talking. Except just to note that we'll have another one in a couple of months, which will deal with spray sealing, particularly in regional airports. And if you've got any other questions or want to continue the discussion, that's how you can get hold of me anytime you like. Thank you.
Thanks very much, Greg. That was another very informative presentation on pavements, and we really do appreciate your time. Thanks to everybody for participating today. There were some great questions there. As Greg said, they sort of tend to come as a rush at the end there, but we managed to get through them all. So thanks for putting all those questions forward. And yeah, do touch base with Greg if you have any other questions that you might like to float with him. So. Just before I do close out, there is a survey on the right-hand side of the screen. You'll see there. We'd please do encourage you to finish that survey for us, because it will just help us with our future presentations. This webinar will be available to view after the fact via the Airport Professional webinar page. So the AAA has a new online magazine called the Airport Professional. You can find that via our website. The webinars are also available on our YouTube channel as well. So if you do have any further ideas beyond the Pavement series of webinars for topics for us to do for webinars, please do shoot through any ideas you may have to events@airports.asn.au. And a final plug for our national conference, which is fast approaching, only 2 weeks away now. And thank you again to Greg, who will be presenting at conference during the technical day. The conference full program can be found on our website, our conference website, airportsconference.asn.au. And in terms of next year as well, we'll be having we have our operations forum event that's in May, but the day before we'll be holding a Pavements workshop, which Greg will also be participating in. So thank you again, Greg, for that as well. The date of that's the 22nd of May, and it will be in Brisbane. So if you need any more information about that particular event, also events@airports.asn.au is the email address to email. This recording will be available hopefully by next week. So do keep an eye out. We will pop something in Airport Alert to notify. And we do thank you again for participating, and look forward to seeing you again for the next webinars in the series, which will kick off again, as Greg noted, in a couple of months' time in early 2018. So thanks again, everybody, and have a nice day.